Hello and welcome back. Panel productivity. This is the standard test condition. Actually, the PV panel is tested under a conditions which is 1000 watt per meter square, 25 cell temperature, not environment, and air mass 1.5. The air mass is a volume of air defined by its temperature and water vapor content. So we have standard test condition and we have nominal operating cell temperature. Nominal operating cell temperature is 800 watt per meter square of irradiance, 20 degrees Celsius of ambient temperature, not the cell, and 1 meter per second wind speed. Peak sun hours. The peak sun hour is very important in the design stage because we want to get the maximum radiation of the sun to get the maximum power output of the PV system. So the peak sun hour is the hours that the sun gives us a maximum radiation during the day. As you see in the morning, the radiation is low. It's increased with the time and it's increased to the maximum at the noon and going down with sunset. Okay, as you see, from 9 to 4, this is the peak sun hour, which give us 1000 watt per meter square. So we design the PV system on these hours and we can get the peak sun hours for any location in the world by PV calculator website, and we will see it next videos. For example, as you see in the left, from 9 to 11 a.m. we have 500 watt per meter square irradiance per hour. So the 2 hours give us 1000 watt per meter square, which is 1 peak sun hour. On the right, from 12 to 1 p.m. we have 1000 irradiance. So we have 1 hour with 1000 irradiance, which is peak sun hour, and on the left we have 2 hours with 500 watt per meter square irradiance. So the two are the same. So the peak sun hour is very important in the design stage. There are some factors affecting the productivity of the solar PV panels, like shadow, dust, and the temperature. Actually, the shadows decrease the performance of PV panels significantly and may generate a hotspot. The hotspot is overheating in a small area and may damage the PV panel. The dust decreases the power output of the PV array up to 50%. Actually, the temperature make high decrease in voltage and low increase of current, result in high decrease in the power output. Here we have the shadow effect on the solar panel. As you see, the IV curve and the maximum power point tracker track the maximum point that we can get from the PV panel. As you see, the shadow is affect the power output significantly, even that if the shadow is small. So we have to ensure that the system is without shadow in the design stage to get the maximum power output from the system. There is a solution for the shadow effect, which is the bypass diode. Bypass diode is integrated with the solar panels in the factory. So what is the bypass diode? Bypass diode actually is another way that the current could go through and complete the circuit. So the PV panels comes with a number of sets, often 3 sets. The cells in the set connected in series and the set together connected in parallel. So when one set have a shadow, the bypass diode carries the current and complete the circuit. See you in the next video and thank you.